Hello everyone and welcome to the second video on introduction to Numpy for beginners. In this video we'll be going over a very important concept when it comes to Numpy, which is Numpy array indexing. We already went over a bunch of useful topics in the previous video, such as the linspace command, how to get started with the random function, the random command, what are 1D vectors, what are 2D matrices, and a bunch of other handful and useful topics. You guys can obviously review the first video if just in case you haven't watched it. In this video we will be looking over how we can pick specific elements from a 1D vector or 2D matrix using indexing, index slicing notation, and and a bunch of other useful topics. So without further ado, let's get started. The first thing that I want you guys to do is to import Numpy. You can do that using import Numpy as np. So once Numpy has been imported, let's say I have a list over here, list 1, and list 1 has 2, 3, 4. List 1 has 4 elements. Now, if you guys have watched my introduction to Python for beginners course, you know how to pick specific elements from a list 1. We can define that variable which is our list, in this case list 1. We can just pass, create 2 square brackets and pass in an index value, and we get that particular index out from that list. But how can we use index slicing when it comes to arrays? Well, let's take a look. I will define a variable by the name of array1, and array1 is nothing but a Numpy array based off of this list over here. And if I were to look at array1, it has 5 elements all the way from 0 to 4. If I were to pick any element from this array, I can do that using the same index slicing notation that I've used for list in my previous videos. I'll just type in my array name, create or type in 2 square brackets and pass in my index notation, run this cell, and I get my particular element, which is based on that array. So index 3 is 3, index 2 is 2, so on and so forth. You guys get the point. And now let's say I have another list which is a 1D vector, but it has a lot of elements. Let's say it's list, and this is list 2. I have defined a 1D vector which has elements starting from 0 up to but not including 15. So if I were to fetch this whole chunk of numbers from 0 to 4, if I wanted to fetch this whole chunk of numbers, I could do that by taking this list 2 over here and telling Numpy that okay, numbers start from 0 and I want all numbers but not including to 5. So I get 0, 1, 2, 3, 4. Yes, so using index slicing, I have told Numpy that return only these 5 numbers from this array. So that's for index slicing. Obviously very similar to how we worked with list in the previous videos, so I don't think there's nothing new here. So what is the basic difference between list and Numpy arrays? I mean, what's the one thing that really differentiates them? Well, this is where the concept of broadcasting comes, and I will go over that in some detail over here. So let's say I've already defined my array, which by the name of list 2, and what I'm going to do is I'm going to define a variable by the name of array2, and it's nothing, this array is nothing but this array is nothing but a chunk of numbers from 0 to 5 for list 2. And if I were to look at array 2, it has 5 elements, 0, 1, 2, 3, 4, and it's an array. Let's say I were to change the first 2 elements inside of array 2. So I would tell Python that for elements from 0 to 2 inside of array 2, I want you to make them 23. And if I were to look at array 2, Python did exactly just that. It took those elements and it converted them to 23. But let's look at the original array by the name of list2, which was used to create this array2 variable. Did that change? Yes, it did. It did change. Even though we only changed the elements inside of array2 over here, elements inside of list3 have been changed as well. And why? Because array2 was created from list2. But why did these elements change? Well, these elements change because of the fact that when it comes to NumPy did not, create a copy of list2 for elements from 0 to 5. It only created array2 as a reference to these 5 elements of list2. Maybe you guys are getting my point. It's array2 is nothing but a view for these 5 elements of list2. It's not a copy. So when we change anything inside of array2, we are indirectly changing elements inside of list2 as well. So that is something you guys have to keep in mind at all times. But let's say if you want to create if you guys want to create a completely completely different chunk of 1D vector from list2, but it is independent from list2. So if I were to make the changes in that particular array, list2 should not be affected by it. You guys can do that. How? I will run that same example. So list2 has these elements. Array2 is what I'm telling NumPy is that array2 is elements 0 up to 5 of list2, but I will define this one command, which is the copy command. And what the copy command does is that it creates, it gives array2 these particular elements from 0 to 5. It creates an independent array for array2, but these elements are completely independent from our original original array over here, which was used to create this array2 over here. So now if I were to, let's say, tell NumPy that for elements from 0 to 2 I want you to make them 90, and if I were to look at array2, I get 90, 92, 3, 4. And now if I were to look at list2, list2 has not changed at all. So this is how you can create a completely independent array using the copy command. So I hope you guys all of this is making sense. Obviously practice makes perfect. If there is something that you guys are not clear with respect to NumPy arrays, please feel free to add your questions in the comments below, and I'll try to get back to you guys as soon as I can. So moving forward, we have went over how we can pick elements from a 1D vector, but can we do the same when it comes to a 2D matrix? Well, let's see that. Let's say I define a list by the name of list3, and list3 over here has list3 is basically a nested list. Yeah, so list3 is a nested list which has element 1 2 3 4 5 6 7 8 9. List3 is a nested list, and if I were to create I'll call this array2, and if I were to create a matrix out of this list3, I can do that using the np.array, and I'll wrap this cast my list3 inside of this function, and when I run this cell, I get this matrix over here 1 2 3 4 5 6 7 8 9. So I have an array2 which is a 3 cross 3 matrix. Let's say I want to fetch this 5 number from here. How can I fetch elements from a matrix? Well, there are two ways of doing this. We can either use the double bracket format or the single bracket format notation. The double bracket format notation is you pass in 2 arguments inside of these square brackets. The first argument is the row number, the second argument is the column number. So let's give this a try. So row number is, this is row 0, row 1, row 2. So I want element from row 1 over here. So this will be row 1. And now if I were to look at columns, 147 is column 1, 258 is column 2, 369 is column 3. But sorry, I take that back. Counting when it comes to index notation starts from 0. So this will be column 0, 147, column 2, column 1, column 2. Let's just run it. You guys will get the point. So value from column 1 and value from row 1 and from column 1 is 5, and I get 1 1. Let's just run this example one more time, but this time I would like to run for the number 6 over here. So number 6 is in column 1, sorry, number 6 is in row 1, column 2. So if I were to run this, row 1, column 2. Horizontal values are rows, vertical values are columns. Sometimes I confuse them. Please forgive me for this. So yeah, this is how we can grab specific elements from a matrix using using index notation. And the second way is the single bracket format. The single bracket format is pretty straightforward. Instead of defining curly brackets for the rows and columns respectively, we can define one set of curly brackets, and inside of this we can define our row number separated by a comma, and then we define our column number, and now we get 6. Pretty easy, straightforward. Now we have looked at how we can fetch elements, specific elements, single digit elements from an array. But what if I wanted to grab whole matrices from this array? Is that possible? Well, let's give that a try. This is a 3x3 matrix. We have 3 rows and 3 columns. I want to grab this 2x2 matrix, which is 5 6 8 9, from this array 2. What I'll do is I'll tell Python that okay, 5 6 8 9, this 5 6 8 9 are in row 1 and row 2. So I'll tell Python that okay, grab all elements that start from row 1 and up to, we'll pass no argument over here. Basically this will tell Python that okay, all elements from n including row 1 and up to the very end. We'll separate this by a comma, and the second argument will be the column number. Over here we'll tell Python that okay, all elements that start from 1 up to but not including to the very end. So we get column 1, column 2 up to the very end. Let me just run this and I'll get 5 6 8 9. Let me run this example again, because maybe I was not able to convey what I was trying to say very well. I have array 2. Let's say I want to grab this 1 2 4 5 matrix from this. How I can do this? As far as rows are concerned, this is in row 0 and row 1. I'll tell Python that grab all rows from up to but not including the second row. So I will get these 2 rows in which my 1 2 4 5 is included, but I don't want this 3 and 6 over here. So how can I reject that? I'll tell Python that grab all columns start from 0 but not including the second one. So Python will return these 2 columns but not the last one, and if I were to run this, I get 1 2 4 5. This is how you can use index slicing notation inside of matrices to grab matrices from matrices. So yeah, I hope that point was clear. Moving forward, the other thing that I would like to go over is, and this will be the last part for this lecture, I want to go over conditional selection. So let's say I have an array, and this array has 5 elements, 1 2 3 4 5. Let's say I want to I were to define a condition on this array. I said greater than 2. When I do that, Python returns an array, but these arrays contain a set of boolean values such as false, false, true, true, true. What Python is telling over here is that your first 2 elements, they are not greater than 2, and the last 3 elements are greater than true. So applying conditions on a particular array on a particular array will return a set of boolean values. And if I want to look at those values which hold true for this condition over here, what I can do is I'll define my array I'll define my variable again. I'll pass a set of set of square brackets, and inside of it I'll pass my condition in array greater than 2. And now only those elements are returned for which this particular condition is true. Array is greater than 2 is only true for the last 3 elements, and only this condition will be returned. So yeah, you guys get the point what I'm trying to say over here. This particular notation will be used extensively when we get to the pandas section, and is also used extensively when we work with NumPy arrays. Conditional formatting is very powerful, and you guys will realize the value of this when we actually work with real data sets from Kaggle. So yeah, that was it for conditional selection. The last thing I want you guys to do is that, let's say you have an array which has elements from 0 to 50. Oops, I've had to 2D, and I decide to reshape this to a 5, 10. So I have this huge matrix. It's a 5 cross 10 which has 50 elements inside of it. We have 5 rows, 10 columns, and I want you guys to practice that index slicing notation we went over for matrices. Basically fetching matrix from a matrix. So let's say, how would you fetch this 15, 16, 25, 26 from this particular matrix over here? I will run one example. So let's say I want to grab this 11, 12, 21, 22, this 2 cross 2 matrix. How I can do that? I'll tell Python that okay, ARR2D, first we will define our rows. So 11, 12, 21, 22, 0, 1, 2, 3, 4. This is in row 1 and row 2. So I'll tell Python that okay, up to but not including the last, up to but not including the third row. So 0, 1, 2. What Python will do is it will return row 1 and row 2 but not row 3. It will not return row 3 because the last number is always exclusive, and the other argument is the column number. So this is 0, 1, 2, 3. So the column number will be 1, 3 as well. And if I run this, I get 11, 12, 21, 22. So this is how you can use double bracket format or single bracket format notation inside of matrices to pick specific matrices from a big matrix. So yeah, just practice with this. Get your hands ready on the keyboard, guys. Just start practicing, put the time in. If there's anything that is not clear, or there's anything that you guys would like me to clear up, please feel free to let me know in the comments, and I'll get back to you guys as soon as I can. That's pretty much it for this lecture. I'll see you guys in the next video. Thank you.